Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Versant. We have Dirk Bartels. Dirk is VP of Strategic Product Management at the company. So, Dirk, welcome to the show today.
Thank you, and thanks for having us.
Oh, it's my pleasure. So, why don't we start with your slides? I've brought them up here, and then we'll follow that with a Q&A.
Okay. Well, what we're going to talk about today is a new product that we are launching this year, and what we're announcing today is a technical preview, which means we have part of the product completed in the development, and we are providing this to our developer community so that they can get early access to the code. We get some feedback from our customers and from the developers, and that influences obviously the final release that we are planning to have sometime in April or May of this year. The product is called Versant JPA. JPA is an industry standard, and I'll get into more detail on the following slides. So moving on the agenda, I want to give you a quick overview on JPA and what Versant is implementing in the standard. This is part of our larger roadmap. We call it the Versant Big Data Roadmap. I want to give you a glimpse of that, so that you better understand how it fits into our overall product strategy, what the developer benefits from, how to use it, where you can download it, and also where developers can leave feedback to us and our development team, how they can contact our developers directly. This is really a shift in our overall strategy. We're becoming much more of an open company. So far, we have been rather closed-lipped in terms of new product development. We had always never had long, pre-release periods, but with this JPA product, we actually changed the strategy and becoming much more of an open company. We believe that's actually beneficial for both the developers as well as our own product development. Moving on to the next slide. Why are we doing this? Obviously, there are databases out there in the marketplace for 30, 40 years, and still that seems to be concerns that people don't get the right data or the right information at the right time. So when I went to one of the big data conferences last year, I think it was Strata in New York, there was a slide that I found pretty impressive. 50% of today's CEOs say that they don't have good information to make decisions, and another third of the CEOs are saying that they may get some information, but they don't trust the information, which really leaves less than 20% of CEOs that say they actually have information, and maybe they just don't want to admit that they have good information or don't have the right information to make a decision. So today, really, when it comes to running a business, making decisions that we have to make very, very quickly, often we just don't have the right information to make those. So we're making gut decisions, and obviously, if you run a very large enterprise, this becomes an issue. So we believe that there's a trend towards new data management and next generation applications. And while we're introducing a standard API, this API is targeted towards new application development that we see in the marketplace happening today around big data and in database analytics. Moving on to the next slide. So why have we picked the Java Persistence API? I actually was involved in at least two industry standards around Java persistence. In the 90s, there was a group called the ODMG, the Object Database Management Group, and we developed a standard so that people that wanted to store objects in a database had a common interface. We started this effort actually with C++, and in the late 90s, when Java became a more popular language, ODMG extended that standard into the Java space. But none of the big vendors really participated in that standard effort. So when Sun introduced the Java community process, we decided to move that into the Java community process. And the ODMG standard became the JDO standard, which stands for Java Data Object. And Java Data Objects kind of ran in parallel with the J2EE efforts, where they give us enterprise Java beans and EJB persistence. And eventually those two groups felt that they have to kind of fold it together. EJB was a little bit too complex, and then JDO was focused too much on pure object databases, and really that created the Java Persistence working group, or JPA working group, and the first stand was published in May of 2006, JPA 1.0, and we currently have an approved standard, which is JPA 2.0, which was released in December of 2009. So the difference between JPA and JDO is somewhat subtle. JPA focuses much more on relational databases. It's quite popular now in products like Hibernate and other object relational mapping tools that basically provide a persistence layer towards relational databases like an Oracle or MySQL or a SQL Server. What we are doing with this API is saying, listen, we have these millions of Java developers out there using already the standard, understanding how Java persistence is the way to go instead of using JDBC or native programming of relational databases. So we can leverage that, but we don't have to really focus at all on the mapping part, but can just focus on making it very, very high performance. And so JPA is basically our transition into this marketplace. We used to support JDO, and we continue for the pure object database people, but for someone who has more traditional training background on databases in Java, JPA, we believe, is a much better standard because it's simply more popular. Moving on to the next slide. So what does it mean for us? JPA obviously is a core functionality for programming databases out of a Java program. And we are using this. We are one of the few vendors that actually have a native object persistence API, which means there's no mapping necessary, there's no annotations necessary. You can actually take objects you store in the database, and it creates significant higher performance compared to any relational system. I will get to that a little bit later. JPA allows vendor extensions, so it allows actually to go beyond the standard, which is not very different from SQL. When you think about it, SQL has a core set of services and functionalities, and then every vendor has their own extensions, may it be stored procedures or what have you. So we kind of take the same approach. We take the core of the language, which really leverages the knowledge that's out there in the marketplace, and then we're adding particular capabilities to our API so that it makes it specific for what we believe are big data and analytics applications. So some of these extensions are distributed databases, so we allow set up clusters of servers and databases so that you can really support very, very large volumes and very many concurrent users. We also support a generic object API, which is the foundation for other language bindings, which basically means you can access the database without the benefit of having the Java class accessible. So you can go in and you can marshal a particular object. So this is good for access via PHP, for instance, or Python or what have you. Thirdly, we have an admin API. This is something that traditionally Versant has been always very strong in terms of embedding the database into an application and make it seamless. So the database is not separate from the application, but can be fully integrated. It's something our customers, especially our OEMs, really appreciate, so that you don't need a database admin. You can essentially automate most of the database administration and maintenance tasks from within the application. We are, and last but not least, we are integrating third-party distributed caches. Again, this is something to mostly increase performance and scalability across multiple boxes when you start replicating your database across several servers. So again, the core is a well-understood API. The extensions are about specific features that are required for these vertical markets we're going to go after, which is high performance, very large database and analytics. From a developer perspective, we have a very good Eclipse integration, which means it's very seamless in the development process when you use Eclipse. For instance, there's a code processor that is automated within the Eclipse project management and so forth. What I also want to mention is that there are certain things that developers are familiar with from object relational mapping and JPA, which is typically that they have to put a lot of annotations in their class code and and then basically direct the mapping via an XML file. That obviously is not necessary at all with our system because it's native. And some of the SQL-like queries, like for instance joins, are things that we don't do because you simply don't need to do that when you have an object stored underneath the JPA binding. Moving on to the next slide, just to give you an idea how this is being rolled out. We have a technical preview we launched in early December. It's available in our developer community as a free download. And that includes essentially everything that you need in order to start writing an application. It has transaction management, it has complete object lifecycle management, and a bunch of other things, including the Eclipse integration. Until April of this year, so basically in the next 90 to 120 days, we are adding specific features to it to make it more scalable and to make it more specific towards these verticals, big data and analytics. For instance, supporting multiple databases and multiple servers and full complete distributed support. A couple of particular APIs that have been proven to be very useful when you work with very large data sets, for instance, fetch groups, the admin API that I mentioned earlier, and also the things like lifecycle callbacks, which allows you to provide a more event-driven programming model. And then eventually towards later this year, so the middle box really shows you kind of where we are with version 1 by April-May timeframe. And then the box to the right is kind of the future or roadmap for JPA over the next 12 months, which is fully support J2E persistence, for instance, the integration of the second level cache, and then some other high performance capabilities like for instance the fault tolerance server and so forth. Again, our focus is always on the enterprise. Our focus is at the high end, where you have lots of concurrency, lots of complexity, and lots of data. We think that this is kind of the intersection where our system provides the most value to the developer. Moving on to the next slide, JPA is really just a component of our roadmap going forward for the next 24, 36 months. Obviously, everybody sees now that the amount of data we deal with on a daily basis has exploded, and that has lots of different reasons for that, and that's probably not enough time to discuss those. But really what we see is that there are traditional transactional applications that need things like a JPA client, and then there are more analytical applications that really work on what we do with the data. Storing data is, in a way, a relatively trivial task. Storing a lot of data becomes a little bit more complicated. Storing a lot of data that's complex is quite challenging, but then actually making something out of the data, so providing interfaces to analytical applications, really we believe is the key. So when you look at this slide here, there are like 3 red bullets. There's number 1, which is the client interfaces. We have the JPA client now. We have a generic API, and we have other APIs for C++. It's still something that a lot of high-performance computing people like to use because it's just the most efficient language on the client. The second bullet is the data ingestion. When you don't have transactional applications that basically people start, more or less typing in the data that they want to store, you kind of look at streams of data, sensors, machine to machine, network traffic, maybe output from a Hadoop job, and what have you. And for that, we are extending our server. This is our roadmap, and providing the programmable ETL adapter API on the server side. So we are trying to avoid basically the double overhead of first putting something on a client that you ingest, and then from a client send it over to the server, rather send it directly from the sensor to the server. The sensor can ingest the data appropriately without having a double overhead. On the right side, you see, which I believe is really kind of the key for all that, what can you do with the data? What can we help the developer to make use of the data outside of the simple questions, the simple queries, and so forth? And this really, I think, what's going to be the key in the future, especially as we have more data, which is how can we connect analytical tools like R or complex event processing or things like a MapReduce to our data sources. And for that, we are working on a programmable analytics API, which again connects directly to the server. The goal here is to avoid overhead of just first moving all the data over the network to a client where the client can process it, but rather have an analytical algorithm asking the server on the server a particular question, and then whatever result's gonna be the result, then the results only being sent over to the client. So again, trying to eliminate unnecessary network traffic, which I think is essential for dealing in high-performance environment with lots of data. So just to give you an idea kind of where this all fits into our overall strategy. Moving on to the next slide, I kind of talked about that. Again, those are the three big product innovations we are working on right now, which is going to be rolled out in stages over the next 12, 24 months. It's the JPA binding, the server analytics framework, and then the server ETL framework. And there will be more announcements coming when we have more details on number 2 and number 3. Moving on to the next slide. So what's in for the developer? Why should the developer care? In the past, I think, and especially in today's world where databases have become, again, something people talk about. I mean, up until like 2 or 3 years ago, nobody was talking about databases anymore. It was just Oracle. It was just SQL. And people felt like, this is, game over. We put everything in a SQL database. And then eventually we saw things like Facebook and LinkedIn and other social networks saying, well, we just can't get it done with a relational database. And they started this NoSQL trend, which is just looking at the systems that are not only SQL or not SQL at all. And all these systems have provided, I think, value at certain levels, but none of them have a standard, which means you end up in a proprietary system that your developers have to learn, and you have to deal with a particular vendor, and if the vendor for some reason doesn't deliver, then you get stuck. So having JPA for us as kind of a NoSQL database really benefits the developer because it's the first NoSQL database based on an industry standard. So most Java developers know already JPA, and actually compared to a relational system, Versant is much easier to use because you don't have any annotations. We do schema versioning and those types of things, schema evolution. So it certainly is something that helps the developer to get started very quickly with JPA and still keep the door open towards, if for some reason Versant doesn't deliver, I can go to an Oracle and get a database there. What the system delivers is significantly better performance. And when you deal with lots of data, this actually becomes not just a nice to have, but a must have. This is about cost. If you can get 6 to 10 times more load on a server, the difference on operating a large, high performance system can be significantly cheaper with Versant. Especially when your data becomes more complex, the system actually becomes even faster. And we actually found out that the JPA binding that we are currently developing is the fastest binding that's available for our database. When you look at just high level, some data on the next slide. This is an open source benchmark. It's called pole position. You can instrument this benchmark with a number of different scenarios. You can put different data models in there, different workloads in there. This is a particular model that looks at concurrency in a complex environment, which does insert queries, updates, and deletes. Typically, what this chart is showing is how the system works with 1 thread, 10 threads, 1 thread, 3 threads, and 10 threads. And you compare basically JPA, which is the dark red, towards Hibernate and MySQL, which is another JPA implementation, and the benefits are anywhere between 10 and 20 factor better performance with Versant. So quite significant, quite remarkable, same amount of data, and this is an open source benchmark you can run for yourself, and you can instrument yourself as a data model that you have, which is something I always recommend. Don't trust any benchmark, run your own, because every data model, every use case is different, and that just gives you kind of an idea how fast the system can be. All right, so how do you get started? If you're interested in that, quite easy. You can go to our developer community. It's community.versant.com. We use agile development for our own product development. So every 4 weeks, after every sprint we do, there's a new version for this technical preview available on our website. The community is quite vibrant. You can ask questions to our developers. You can look at discussion forums, and you can post your questions there to the community as well as to the developers. So an easy way to get it. It's free. It doesn't cost you anything. It's a very simple registration process, and you can get going. After you download the software, we recommend using Eclipse as an environment, but you can also put it into scripts. And there's a step-by-step tutorial included, as well as very specific examples for certain features that the system has. So quite easy way to get started and get going with the system, get your hands dirty, so to speak. Next slide. If you look for more information on the system, again, the best way to do it is go to our developer community. We have about 100,000 developers registered, so it's a quite vibrant place to go, and we invite everybody to participate and ask questions and give us feedback on the system. That would be fantastic. And that kind of brings me to the end of this presentation. So if you haven't heard about Versant, we are helping innovators build high-performance database applications since 1998. So we do this for more than 20 years. We have lots of high-profile customers. I believe more or less everybody who is touching a Versant database every day. When you pick up your mobile phone, most of the OSS systems of the telcos are running a Versant database. If you book your ticket to New York via Travelocity, it's something that the seat inventory system comes from Sabre, and Sabre runs on Versant. So lots of really interesting high-performance, mission-critical applications are running today's world, and we think this is another great way that we're extending our market via the JPA product we're developing.
Well, thank you for that, Dirk. I'm curious, Versant's been around, as you said, 20 years. Is this the first time that you've gone the open route, open source?
Yes and no. We actually acquired an open source company about 2.5 years ago, 3 years ago, called DB4O, Database for Objects. It's a very small, kind of small footprint embedded database. It's actually quite popular, and we acquired these guys, and we really learned a lot about open source, and we liked what we learned. We found that becoming more open is really helping us to better understand what customers want to do with the system. I don't think that the customers really want to get the source code, but just having the ability to access the system, quite easily, don't pay any money for it, get your hands dirty, understand it, following industry standards instead of having proprietary APIs. I mean, those are things that we have learned from DB4 are very, very valuable, and that's why we are changing our strategy in that regard. So
it sounds like it's more of you made the shift for performance and customer reasons. Rather, it doesn't sound like a big business shift. Like you're steering the whole company towards a different model. Does that sound right?
Yeah, I mean, our model continues to be mostly. I mean, when you look at our most of our customers, they're embedding our system. We have a fairly strong footprint in ISVs, independent software vendors that are building packaged applications, and those packaged applications become much more hosted applications and internet services these days than they used to be. Obviously, there's a shift in the industry towards that. We have a fair amount of OEMs like for instance Ericsson or an Alcatel-Lucent or an Avaya that build telecom equipment, and part of the equipment is a software component, typically OSS, an operating support system. And this is something where embeddability is really the key. We're not perceived as a standalone database like an Oracle that can serve 20 different applications. Typically, a very application-specific database our customers develop, and that's reflected in our APIs. It's reflected in our business model. We do a lot of these ISV OEM contracts that don't work off an enterprise list, and there's certainly a transition in terms of business model as we see cloud computing becoming more relevant in the next couple of years. Platform as a service becomes more relevant. JPA is, for instance, the preferred API for Cloud Foundry. So when you look at Cloud Foundry, they have a JPA adapter, so we're going to plug right underneath the Cloud Foundry systems for private clouds, and then become part of a platform as a service system. This is really where we believe things will go.
So kind of a wrap-up question here, Dirk. Do you think this move to being more open, do you think that'll help make Versant more agile and more responsive to customers and able to innovate faster?
Yeah, I do so. I strongly believe that, absolutely.
Well, terrific. Well, hey, Dirk, I want to thank you once again for coming on the show today.
Thank you for having us. It was great.
You bet, you bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.